Hello and welcome to this higher tier GCSE lesson on pyramids. For your Do Now task, you need to calculate the surface area of these shapes. Pause the video while you work through them. Right, let's have a look at those answers. The first one is 148 centimetres squared. The second one, 85 centimetres squared. The third one, 228 centimetres squared. And the fourth one, 416 centimetres squared. So today we're going to have a look at the volume of a pyramid. And we're going to be able to also calculate the height if we're given the volume, and then apply this to problems involving compound shapes. So first of all, a definition of a pyramid. So a pyramid is a 3D shape with a base from which triangular faces rise to a common vertex called the apex. So the base can be any polygon, but usually we will be looking at triangles or squares. So here's a diagram. So you can see the point at the top, the proper name for that is the apex. So the formula for the volume of a pyramid is this. So let's write this down. V equals 1/3 times base area times height. Okay, let's have a look at an example. So make sure you copy this down. So we've got a pyramid here. We can see the lengths of the base are 5 and 4. So that's a rectangular based pyramid. And we've got the height is 6 centimetres. So the height is always going to be perpendicular to the base. So the first thing to do is find the base area. So that's going to be 20 centimetres squared. And then use the formula to find the volume. So 1/3 times by 20 times by 6. And that gives us 40 centimetres cubed. So have a look at these ones. Make sure you show every step of your working. Pause the video while you work through these. Okay, let's check the answers. So question A is 56 centimetres cubed. Question B is 168 centimetres cubed. Now question C looks a bit different because the apex is not in the middle. The previous ones we've seen, they've all been above the middle of the base, but we're looking at the perpendicular height compared to the base. So the height there is 12 centimetres. And the volume is 1040 centimetres cubed. Question D, similarly, the height has to be the value that's perpendicular to the base. And we've got a volume of 84 centimetres cubed. And lastly, we have got 160 centimetres cubed. Question 2 says show that the volume, and that means that we can't use the 270 centimetres cubed in our answer. Just check that's the answer that you get. So this is the working, so you should write down the working. 1/3 times the base area times height. So you've done 1/3 times 9 times 9 times 10, and that equals 270 centimetres cubed. So you're using working to show that you've got the answer of 270 centimetres cubed. Okay, challenge question here to have a think about. So what we've got here is we've got 6 pyramids that each have a height that is half the side of the square base. The diagram make that clearer for you as to what that means. So the first thing to think about is explain how they can fit together to make a cube. So pause the video while you have a think about that answer. Okay, so looking at the picture, that can really help. So if you put the apexes of the pyramids together, they'll be in the middle of the cube, and then the 6 square bases from each pyramid will form each face of the cube. Okay, so let's look at part B. So it's quite challenging to come up with this sort of explanation yourself. So if we have a look and we say that the side of a base is length A, so that's each length on the cube is A, then the height of the pyramid, because they go to the middle, they will be half A. And the total volume of the cube is going to be A multiplied by A multiplied by A, so that's A cubed. But that's also the volume of all 6 pyramids together. That means one pyramid is 1/6 A cubed. which can be written as a third times half A times A squared. So that gives us a third. The half A was the height and A squared was the base area. So really well done if you came up with that yourself, because that is quite challenging. Okay, another problem solving question for you to have a think about. Right, let's have a look at this. So the design is now a more conventional shape. It's got the same square base, but it's got a flat roof. And crucially, the volume is the same. That means the height is going to be a third of the height of the pyramid. So we're going to have 6.9 metres. Okay, another couple of questions looking at the formula for density. Don't forget that. Pause the video while you work through these ones. Okay, question 6 then, we end up with 208 grams. And question 7 is 1.5 grams. Right, let's have a look at the silver objective now. So this is where we are given the volume and we need to calculate the vertical height. So a sketch always helps. So we can see there we've labelled it, we're told that a pyramid has a square base of side 8 centimetres and we've got a volume of 320 centimetres cubed. We need to work out the height. So I've labelled the height h. So we know the volume, we've got a third times by 64, which we get from 8 multiplied by 8, and then times h is going to give us 320. If we simplify that, we've got 64h over 3 is 320. So in one step, we've multiplied by 3 and divided by 64. That can then be calculated to get a height of 15 centimetres. Okay, have a look at these two questions. Pause the video while you work through them. Okay, question 8. So remember, show that question. You can't just use the value 6 and then work out the volume. You've got to start with the volume and get to the height. So we've got a third times the area of the base, so 6.4 times 6.4, times h for the height equals 81.3. So the height is going to be 3 times 81.3 divided by 6.4 times 6.4. And then that value has been rounded. So if you've used 6 in your question and then got an answer of 81.3, that wouldn't give you marks in an exam, because you have not shown that, you've proved it works rather than show that it's the only answer. Okay, question 9. We have got a height of 14.4 centimetres. Okay, looking at the gold level questions now, so we're working out the volume of compound shapes. So pause the video while you work through these. Okay, the first one, we have a volume of 73.3 metres cubed. The second one is 45 metres cubed. And the third one is 3,250 centimetres cubed. So we've looked at calculating the volume of a pyramid, the height of a pyramid, and some compound shapes that include pyramids. And we'll finish with this final question. I'll leave you to do that and then go through it at the end. So pause the video while you work through this. Okay, so let's have a look at this together. So what we've got is a pyramid with the top 5 centimetres chopped off the top. And that remaining shape is called a frustum. Hannah says the volume of the frustum is 26/27 of the original pyramid. And evaluate Hannah's comment. So we've either got to show that it's correct by using loads of working, or use our working and come up with a different answer to show it's wrong. So the first thing to do would be to calculate the volume of the original pyramid. And that would give us 270 centimetres cubed. You can see the working here to then also get the volume of the little pyramid, the bit that's been chopped off. And that gives us 10 centimetres cubed. So the volume of the frustum, the part that's left over, is 260 centimetres cubed. So if we look at the volume of the frustum as the numerator of our fraction, and the denominator is the volume of the pyramid, So how much of the frustum is the pyramid? We've got 260 out of 270, which simplifies to 26 over 27. Therefore, Hannah is correct. We'll look at frustums in more detail on the next lesson, which will be a challenge topic. So if you're interested in looking at that in more detail, do look at that lesson. Okay, well done today. I will see you next time. Goodbye.